Okay, today's lesson is going to be on logarithms. Again, it might be a topic that some of you guys are familiar with and some may not be. So, logarithms. Logarithms are another way to describe an exponent. So having said that, if we look at it in equation form, it'd be anything that is raised to something other than a 1. So it could be raised to a half power, or it could be raised to something greater than 1, or something greater than that. So we're looking at functions that are nonlinear. Okay, so logarithms. And we will discuss this again in more depth on our Wednesday class. So let's just start with a standard exponential equation. So let's say it's x equals some other number, we'll call it b, and it's raised to some power. So we have a variable, we have some base, some number base, and then we have another variable. So we have an x and a y. So this is where it becomes an exponential form. Is this y? We're really not sure what it is. So let's just let's take a look at that. What if we just had a base and call it, we'll have base 4 for this case. Could be any number, could be a fraction, but let's just say it's a base of 4. It can't be a negative number, so b has to be greater than 1. B is greater than 1. So let's just in this case we have 4. So we have an x and a y. Let's put y as a 2. Our exponent is 2. Our base is 4, and our exponent's 2. You could probably figure out what x is. X has to be x 4 squared, so x has to be 16, right? All right, so logarithms allow us to use a little bit of different format to still discuss exponents. And the reason why logarithms are used are, again, in engineering or science or even in finance to describe some modeling of some phenomena. The Richter scale with earthquakes is a common use of a logarithmic scale. And we'll talk about it when we see each other again. So if we're going to change this format, this is the exponential format because we have an exponent, we're going to convert it into a logarithmic form. So again, this is how I do it so I can keep myself organized. I know the b is the base. Okay, so we're going to call the log. We're going to put b in that base spot. And we're going to have an exponent, which is y. Okay, so and an exponent and a log are the same thing. We're talking about the same thing. So I usually put the b first. It's a little bit below the log, and it equals y, and y is the exponent, and that must leave x for right there. So we would just read this in one of two different ways: the log of x base b, or log base b of x. It's saying the same thing. It's like f of x, or when you're talking about functions, in this case logarithm, you can say log of x base b. Okay, so if we kind of use this example, and I just changed it from a capital to a lowercase l, but log b was, our base was 4, and our exponent was 2. So how to look at this to solve it this way, we'd say, okay, 4 is our base, 2 is our exponent. So 4 raised to the second power is 16. So we could finish this off and say that's the case. Log base 4 of 16 is 2. 4 squared is 16. 4 to what power is 16? 4 to the second power is 16. Okay, so let's continue to talk about that. We'll keep those top examples there. And let's start on this side this time. We can have the base b be anything. It could be a fraction, could be anything greater than 0. Fraction or 1 or 2 or 3. In this case, we have base 10. So to solve this, your thought process can be 10 to what power is 100? 10 to what power is 100? 10 to the first power is 10, so that doesn't work. But 10 to the second power, 10 squared, is 100. So the log of 100 base 10 is 2. Back on this side, our base is 10. We're trying to figure out what y is, and our number x is 100. So 10 to what power is 100? 10 squared is 100. Okay, so that's the same thing. One is in exponential form, and one is logarithmic form. Okay. So what would x be here? Log base 7 of x equals 2. I'm just kind of going back and forth the two acceptable ways to describe this. So 7 squared, 7 raised to the second power is 49. So x would be 49 in that case. Okay. If you look at your calculator, if you use your phone as your calculator, go into the turn sideways, like when you use sine, cosine, and tangent, you'll see 2 different logarithmic functions on your calculator that you can use. One is that, log, log. And the other one could be different things for different calculators. Sometimes it's that. And sometimes it's that. So log, and this one is ln or capital N, depending what your calculator is set up. It could be one of those. But this log is a specific base. This is log base 10 only. Log base 10 only. So you can use your calculator for some of these problems, but the only criteria, it has to be base 10. Okay, and that's called the common log. And the common log is what it's described. It's the most common logarithm, and it's the base 10. This is what the Richter scale for earthquakes, the measurement of earthquakes are used. It's the common log. And if you have an earthquake that measures 4, it has some amount of earth disturbance, and if it went to a Richter scale of 5, it's not just 1 greater, it's actually a factor of 10 greater. And if it goes to 6, 6 is 10 and another 10, so 100 times more earth movement than a Richter scale of 4. Okay, so that's one place where logarithms are used in our everyday life. This other one is the natural log. Natural log. And the natural log is when the base is the lowercase e. Lowercase e is the natural number, and the natural number is something like that, and it goes on forever, like kind of like pi does. It's a rational number, but this is a number that we can use for the natural log. The natural log is used in several different places. One is in finance, when you're looking at returns on investment. Sometimes the natural number is used to figure out your returns of an investment. It's also used on the multiplication of bacteria, how it grows. And so the natural number is used in some forms of science, finance, and engineering to calculate different things. So that's another one that you can use in your calculator. If it's a natural log of a number, you can just put into that number, hit natural log or hit log, and it'll give you the answer. So if you want to check that out, let's say the log of 1,000. If it doesn't show a number here, you automatically assume that it's the common log, base 10. So log 1,000, even though there's not a number here, it's base 10. So 10 to what power is 1,000? So if you put that in your calculator, hit 1,000, and hit log, you will get the right answer. And in this case, it is a whole number, and you should get 3. 10 to the third power, 10 to the third power is 1,000. Okay. So your calculator helps you determine things that aren't so easy with the common log. So say it's 500. What's the log of 500? Log of 500. First, before you put it in your calculator, it's the base 10, it's the common log. 10 to the second power is 100, and 10 to the third power we just did was 1,000. And so we know the answer is between 2 and 3. Between 2 and 3. So that's 2.5 or 2.6. Yeah, something like that. So, okay, anyway. So that's the common log that you use your calculator. If it's anything other than 10, you're not going to be able to use your calculator. You have to do it the long way that we're talking about in the calculation, changing your logs. All right. All right, so the next thing I want to talk about, and again, we're going to talk about some more depth on Wednesday, but I want to introduce some things to you, and then, so when we get together on Wednesday, it's not brand new and fresh. You have a little bit of background. So the next thing we're going to take a look at is the laws of logarithms. Laws of logarithms. Okay, so there's 3 laws of logarithms. Let's change color. Not coming out very good, so let's stay with green. All right, so the first law of logarithms says that if you have a log and it's base b, some number, some base b, could be anything, as long as it's greater than 0. Some base b, and you have 2 numbers or variables or functions, 2 parts to our logarithm, our log base b, m times n, well, that's the m. You can expand that out to say that's the same thing as log base b of m plus log base b of n. Okay, so this is just an expansion. The first law of logarithms says that if you have 2 functions that are multiplied together that have some base b, you can expand it out to, notice that this has the same base, this doesn't change at all, and it's m, log of bm, plus the separate log of bn. Okay, so let's do a quick example there. Let's say log of base 7, and you have, let's just say it's that, 24x, 24 times x. We could expand it out as log base 7 of 24 plus log base 7 of x. Okay. Notice that the bases have to be consistent, and then you can break apart the things that are multiplied together. If they're multiplied together, and it has a plus in between the two logarithms. The second log of logarithms, it follows that, but it's the inverse of multiplication, which is division. So we could have log base b m divided by n, and we can expand that out as log base b m minus log base b n. So notice that it kind of follows a lot like the multiplication, is that you have the m divided by n now, and so you have a negative sign in between your two logs. So the negative and the division follow each other, and again, the consistent part is that it all has to have the same base. So for example, if you have a log base 4, and you have 5x divided by x squared, you could expand that out to be log base 4 of 5x minus the log base 4 of x squared. Okay. All right, so there's the 2 of the 3 laws of logarithms. Let's do the third one. The third one is if you have an exponent. So log, again, we have some base b. And now we have m raised to the n power. Raised to the n power. And if that's the case, if you have a function and is raised to another number or function, this n can be brought out in front of the logarithm. So you can rewrite that as n log base b of m. Okay, so if you had log, let's say it's base 8, and you have x to the 4th power. If it helps you solve the situation, solve the problem, we can move that out to the front. And solve it at that point. Okay, so we'll use all 3 of these laws to solve for problems, depending on the situation. I don't want to get into that too far right now, because I want to just, since I think a good portion, maybe half, this could be the first time you've seen logarithms, so not like the sine and cosine where we did a whole bunch of periods in one time. I'm going to kind of split this up a little bit. So we're going to come back to the laws of logarithms when we see each other Wednesday, but I wanted to introduce you to that. All right, so this is in your book, your Algebra 2 book, all this information. But for Wednesday, this is your assignment. Page 456, number 12 and number 13, and then 20, 21, and 22.